you were dealing with fractions in grade school. By the way, those of you listening, we're on page 375. This is section 7.3. It's called multiplying and dividing rational expressions. It could just as easily have been called multiplying and dividing fractional expressions. Rational, fractional, percentage. And when you multiply and divide fractions, it's not very hard, is it? You multiply and divide fractions, you multiply the top times the top and the bottom times the bottom and reduce it. Or, better yet, you look at the top of one and the top and the bottom of, well, you have two fractions and you can cancel things out before you multiply them. As long as the factor is on the top and the bottom, you can cancel it. Right? That's a better way to go. You'll see that. And if you're doing division, if you're doing it with division, all you got to do before you begin is take this one over here and turn it over. And that becomes a multiplication problem. Right? And you do the same thing. Cancel things, factor things, cancel what you can, and move on. That's today. It's not hard. People find this to go pretty quickly. Look at the title of the next one. The title of the next section is found on page 383. Adding and subtracting fractions is much, much harder. Why? You can't add or subtract unless the denominators are the same. And when you've got expressions on the top and algebraic expressions on the bottom, that becomes more of a daunting task. And then look at the next section, 7.5. This one's called solving rational equations. No, it isn't. And that's a good, that's a rational thought. It's a reasonable thought. Rational. Here's what I want you to notice so you can get a feel for what's coming up. Notice, go back to 7.3. That's the one we're doing today. And go to the exercises on page 380. Are you there? And look at all the practice problems, the ones where they just present things to you. There's no context. Look at all those, and does anybody see an equal sign anywhere? No. We are practicing simplifying things on this, factoring and canceling. That's what we're going to practice on this. Look at 7.4 exercises. That's on page 388. Look for an equal sign. Can't be found.
But there are.
Go to 7.5 exercises on page 396. It's nothing but equal signs now. So get that separated in your mind. We're going to practice the four operations with simplifying on 7.3 and 7.4. We're going to multiply and divide today, which is easy. We're going to add and subtract tomorrow, which is not so easy. And then we're going to set those aside in a file folder because those are simplifying expressions. And then we're going to solve equations with fractions in them. That's a different idea. Okay? So, for 7.4, which is a little easier, we're going to take a look at those today. And see how you handle that. Okay. On 7.4, let's just jump right to, no, let's not. Let's actually do something like this.
Miss J?
Yes.
Are we doing 7.4 or 7.3? 7.3.
We're doing 7.3 today. 7.4 is coming up like tomorrow, but today it won't be as hard. Kind of get your feet wet on how to deal with these things when they're fractional. But if I had something like this, 35/16 times 8/7. If I was asking you to multiply those two things, the first thing that you should do is factor what you can and then cancel. Now I realize that you guys all see this because you're very familiar with numbers. You're very good with numbers. You see that 7, which is down here, and this is a times. It has to be a times, not a plus. That this 7 right here will go into this 35. So will this 8 go into this 16. But what I want to demonstrate for you is not your wonderful numeracy skills. I want to show you how on this that you're familiar with, how it's going to go when we get fractional. Okay, that aren't so familiar. And this is how it would go. You would get this problem, and then you would say, okay, first thing I got to do is factor if I can. So this would be 7 times 5. and then times 8, because that's what I want to do is multiply this times this. So these are all going to be on the top with a time sign in between, right? This is 7 times 5 times 8 over 2 times 8 times 7. That's what you're going to do. You're going to factor everything and dump them into one expression, and then cancel what you can. And then write down what's left.
That's pretty cool.
Did you catch that? So, this is how it's going to work with fractional expressions written in algebra. I'm going to jump to example 3. And I've got 7 over 9x squared. What's it multiplied by? Example 1. No, not example 1. Example 2. I skipped example 1. No, I'm clear on example 3. Give me that. 3x minus 3x squared.
Where are you?
7. Yeah, where are you?
Oh, I'm on 7-4. Okay, let's go back. Sorry, everybody. That was really bad. I'm sorry. Try to gather together with me again. Let's do example 2. On the proper section that we're supposed to be on. No, let's go ahead and do example 1. I'm on the wrong section. Sorry, I gotta get my mind back together again. Okay, on example 1, read it to me, please. Numerator.
So x squared
Minus 4x.
Yeah. Minus.
Okay, over.
It's minus 12.
Oh, 12. Thought I heard a 4.
X squared minus 4.
Okay, now this isn't quite like this because this is taking a single. And this one right here would be like doing this. If I had 36 over 18. No, 16. That would be more like just having a single expression. And what we would do on this one, as opposed to this one, it's very much alike. But what we do on this one is factor the 36. That would be, let's see. If I factored it completely, it would be 6 and 6, 2, 3, 2, 3. So I'm going to rewrite 36 as 2 times 2 times 3 times 3. Have I lost anybody yet? Okay. I'm going to take the 16, which is 4 times 4. That's 2, 2, 2, 2. 2 times 2 times 2 times 2. Yeah? I'll cancel again. And the temptation that's going to be, if you're doing just numbers, would be to multiply what remains. But you're not going to do that. You'll just leave it in factored form. The answer to this, if we were doing it with algebra like that over there, we would just call it 3 times 3 over 2 times 2. Leave it. Okay? All right. So tackle this one now. The objective is to factor and cancel. Over there, they were just I just prime factored everything. Here, we're going to factor using our skills with factoring polynomials. So this would turn into, how does that factor? What factors of 12 subtract to be 4? 2 and 6. No? Yeah. And which one's positive?
2.
The 2 and the 6 is negative. That's how we get the negative 4 over here. Remember?
Yeah.
If you're not a very good factor, this is going to take you a while. On the bottom, how does that factor? Or does it? What is it? X plus 2 and X minus 2. Yeah? Okay. So then we cancel this. And we're left with, for an answer, X minus 6 over X minus 2. People are always tempted to cancel those X's. Get that out of your head. It's the most common algebra mistake made, but it is a mistake, and it's a huge one. These are not factors. Neither is this 2 a factor that will divide into that 6. Every one of these pieces is a term. Terms never cancel. And I don't know if this will help you at all. I wish it would, but if you have 3 plus 5 over 2 plus 5, that is not 3 halves. That is 8 sevenths. Cannot cancel terms. Terms are things that are added and subtracted. They are not eligible. The reason I was able to cancel these two is because the whole thing, the X plus 2, they were both being multiplied by something. That makes them factors. Cancel. not terms. Or even pieces of terms. If you have 2x, I realize that 2 is being multiplied by x, and you have x plus 3 down here, those x's are still not eligible. Well, even if I just had x down here, that x is not eligible. You go, it's being multiplied by 2. No, it's part of a term that's being added to something. That x is not eligible. So terms or pieces of terms cannot be canceled. Get it out of your mind. Happens all the time, but and if you do it, I won't get angry with you, but I will get angry with the mistake, and so you may hear my voice rise a little bit. It's a big deal. So be careful. All right. Now, this is the answer, but it's always a big but. This is not all of the answer. All of the answer is this. X minus 6 over x minus 2. X cannot equal negative 2. Here's the discussion on that. Hopefully I won't have to do this every single time. Maybe it'll be clear to you. The reason why I don't write x cannot equal negative 2 or positive 2 is because what remains here, it is very clear that x cannot equal 2 because it was left over. This is what was left after we canceled everything. And for people who know how to read rational expressions, it's very clear x cannot be 2. It's not so clear that it can't be negative 2, but you can't see that anymore. See these things that canceled? There was, in the process of getting to here, there was a chance of dividing by 0 right here if x were negative 2. We lost that. We can't see it anymore, so we have to clarify that x cannot be negative 2. It also can't be 2, but that's clear. It can't be negative 2 because we lost that factor in the bottom, where if x were negative 2, we would have had division by 0. See over here? In the original, x can't be 2 or negative 2. What happened?
I just choked on my water.
Oh, that is funny. Okay, do you all understand why I chose just negative 2? These are called the restrictions on the domain. So you have to put the finalized answer after you cancel. Then you got to look back at what you canceled and disallow any values that will cause this one to be 0, the one you lost. Okay, moving on. The next one actually is a multiplication problem, and all that means is there's more factoring to do than we had here. Somebody read example 2 to me. Ooh, this is a strange one. Okay.
8x.
8x to the third.
Then 7. I mean the y, sorry.
Y to the 7th?
Oh, just y.
Just y. Okay.
And then underneath it is 2x y squared times 7x on the top.
Over here?
Yep.
Okay. 7x.
To the fourth.
Okay.
And y to the third.
Okay.
Over 4y.
4y.
That's it.
Okay. That's it?
Yep.
Okay. All right. You could start whacking things right here, and it gets really, really messy. I can show you that in a minute if you like. I'm going to get rid of this because what I'm about to write to show you the actual concept that you don't have to do it this way, but I want to show you what's going should be going on in your mind as you do this. What this actually is, folks, is 2 times 2 times 2. That's the 8 factor. X, y. And then coming over here, since it's all multiply, I've got a times 7, which is already prime, it just stays. X, and y. I know, that's what you're asking. Down here, 2 is prime, x, y, and then a times, and then a 2 times 2 for the 4, and a y. Yeah?
Yeah.
That's how it all spreads out. I do not recommend you do this unless you're getting problems wrong routinely. Then you may want to go back to this and do what you can. Even though I didn't put dots between everything, I did the numbers, and I did right here to indicate those times. Every one of these things on the numerator is being times by everybody else, and so are these. There's no addition or subtraction, so there's no danger of canceling a term. No danger. So we start whacking things. 2, 2, 2. All the 2's are gone. All I'm left with for numbers is a 7. I'm going to write that down. Just keep track. Okay. Now I'm going to cancel x's. I don't have any x's to cancel. There's nothing on the bottom I can cancel, so I'd start.
There's 1x.
Oh, yeah. You're right. I missed it. Good thing you're watching. So and when I cancel my x's, if I go like that, I can't tell that I've canceled it. So I obliterate them. Okay. So that one's out. Now I've canceled all my x's and I count them up. 1, 2, 3, 4, 5, 6 of them left in the top. I don't need to look at x's anymore. Now I'm looking at y's. Here's one, cancel that one. Here's one, I got one over here. Here's one here, got one over here. And there's nothing left in the denominator. But what I have for y's in the numerator is 1, y, right? When there's nothing left in the denominator, it doesn't mean a 0, it means a 1. So this is the answer. What restrictions?
Would it be that x and y can't equal 0?
X cannot equal 0, exactly, and y cannot equal 0. Since they're two different, you have to write them two separate things. You can't write x and y cannot be 0. Unless you could write it out in words that way, if you wanted to. This is the way they expect it. Do y'all see why x and y can't be 0?
Yeah.
Because both of them were in the denominator at one time. If this x was not here to begin with, then we would only have to restrict y cannot be 0. Okay? There wasn't much factoring involved here, except for to pull apart the 8 and the 4. There was no factoring. Why? Because everything was already times. All the factors were exposed here. Now, if you didn't want to stretch these all out and count and cancel and all of a sudden take all that time to write it out, then if this problem were presented to you like this and you're pretty good at this, then this is how messy it gets. But if you can keep track, this is what goes on. Here's what I would do to begin. I would say, okay, that 2 goes into that 8, leaving a 4. Still dealing with numbers. Oh, there's a 4. I'm going to cancel that 4 and that 4, and there's no numbers there. Nothing's going to cancel with the 7, so I'll leave him alone. Over here, I've got an x here, and if I cancel it with an x up here, it'll leave me with 2. See how messy it's getting? And I look for other x's. I don't see any. Okay, so now I'm on my y, so I'm going to take care of, I'm going to knock this one out, leaving me with a 1 here, so I'm just not going to put anything. And then over here, oh, I could take this y out now with 2 of the, or one of these. That leaves me with a 2. Oh, I could take this one out, making this 2 a 1. I don't even need to write that anymore. And now let's see what I've got left. I've got x squared. See, it's hard to tell what you have left when you do it this way. X squared, I got a 7. Oh, I got 4 more x's there. And,
1y.
oh yeah, that one little y over there, how his exponent scratched out. Then I got to look at what I canceled. I obliterated that x, and I canceled at least one y, so that means that x can't be 0 and y can't be 0. So you can do it that way. That's messy, but it's more concise than that. So you decide what you want to do, but keep track. I will tell you one thing. It's difficult for me because I'm a smaller person, shorter person with short arms. So when I'm doing work up here, folks, it's like you doing work like this. Well, I can't see everything. Neither can you. So when you get up out of it like this, it'll be easier for you to keep track. I got my work this close to me. That's why I couldn't see that Y or that one over there. I have to move my head and it. All right. So should be easier for you to do it that way if you want. Okay, now we're going to do example 3, and this one does have polynomials instead of just factors. This was only made up of factors. Factors everywhere. Now we're going to do ones where the polynomials are here. We got to come back to factoring like we did on the one I raised. So, since I have to stay on this board to be recorded, we're going to get rid of this stuff. Okay, now let's take one that's really what you're going to be facing most of today. This is all get your feet wet. Now we're going to toss in the deep end. 3x minus 3x squared. Let me read it. What's it over?
X squared plus 4x minus 5.
Times?
X squared plus x minus 20.
Ooh,
Over
okay.
3.
And what?
Over 3x.
3x?
Yep.
Oh. So that one's not going to need factoring. There's nothing in. All the rest of these we're going to at least need to try. So start pulling things apart. The very first thing, anytime you're required to factor, is to pull out what's common. I got a 3x coming out of there. Ooh, remember what I wrote over here? That's going to go. So just don't cancel things till everything's all factored. 3x, and then what's left here, if I pull a 3x out of there, is a 1 minus x, right? Is that right?
Yeah.
Okay. Now I'm going to keep working across the numerator because all this is a times right here. So I'm just going to start factoring this one like this. They're all going to be the numerator. And I get factors of 20. Well, because there's a 1 right here, I can just put an x and an x. Factors of 20 that subtracted be 1 are 5 and 4. Which one's positive?
The 5.
The 5, the 4 is negative, okay. On the bottom, I've got, what does this factor as? Uh,
5 and 1.
So x and 5 and 1, which one's positive? Are they both?
5.
5 is positive, minus 1 gives us the positive 4, right? And just for the sake of being consistent, that 3x is the very last thing, but I'm used to seeing stuff like that on the front. So I'm going to put it on the front if that's okay. Besides that, puts it closer to this, it's easier to see. I'm going to cancel it. You could put it back here as long as you realize they're cancelable. So I'm going to lose the 3, I'm going to lose the x, I'm going to lose the x plus 5, and can I cancel these?
No.
Actually, you can. But you have to account for it in some way or another. So let me have a little discussion about that for a minute, okay? So leave this alone for just a minute. We'll come back to it. You were told in elementary school that, you probably weren't told in these kinds of words, but you were told that subtraction is not commutative. In other words, you can't subtract in any order you want. And specifically, 3 minus 8 is not the same thing as 8 minus 3. Right? You can't just reverse it. And they stopped there and left you alone. The cool thing is, if you do look at that, it is true that 3 minus 8 is not equal to 8 minus 3. But look at what it actually is. What's this? Negative 5, and what's this? 5. They are always related. They're just opposite in time. There's opposites of each other. You reverse, you add an extra negative to your answer. 8 minus 3, that's 5. If you go 3 minus 8, it's still 5, but now it's negative. You with me?
Oh, yeah.
In other words, we could write this. This is true right here, but this is also true. 3 minus 8 is the opposite of 8 minus 3.
Wait, so then if we subtract, so if we cancel that out, then the end product would have to have a negative, right?
Yeah.
Okay, that makes sense.
There'll be an extra negative in the end product. There may be another one it'll cancel with later, but
Yeah.
what I'm saying is that if you have 3 minus 8 over 8 minus 3, that's just negative 1.
Yeah, because then she's
Negative 5 over 5. It happens that way every time. And so if you have x minus 1 over 1 minus x, that's negative 1. In other words, you can cancel this, but you have to account for it with a negative. So when I use that property over here, I'm going to go ahead and cancel these and stick a negative out here.
also
There's your negative 1.
Yeah.
See it?
Yeah.
Okay. So these were in reverse order. So I am going to cancel them. They were subtracting. If they were adding, it wouldn't matter because 1 plus x and x plus 1 are the same. You just cancel those. But if it's subtraction and they're reverse order, you can cancel them, but you have to account for it with a negative. So what we have left here, folks, is negative x minus 4.
Which is negative x plus 4.
You could write it that way, but again, I told you we're going to leave things in factored form. Our answers are going to be factored. So it's okay. I understand that. But we're not done.
It'd have to be
Y. I mean, X is not.
X cannot equal
0.
0 or 1
Or 5.
or negative 5.
Oh, yeah.
Look at the ones you canceled. Here's your 0. Can't be 0. Can't be 1. Can't be negative 5.
I thought that we couldn't take out the 3x.
Why? Why did you think that?
Oh, wait, never mind. I see why.
Are you sure?
Yes, you're
Yeah, because of 3 x's.
Okay. So all understand the restrictions? You understand how that thing whittled down to almost nothing? Got an extra negative though because we had a reverse subtraction. Who's that?
That was very good.
Okay, moving on. Okay, next question. Turn the page.
I figured it out.
This one's a multiplication. We have another multiplication, but this one doesn't look like two fractions, but it is. It's x, what is it?
X plus 2.
X plus 2 over
X cubed minus 27.
minus 27 times.
In parentheses.
Okay, go ahead, just go.
X squared plus 3x plus 9.
Plus what?
9.
Plus 9. And that's over 1. That's understood. If there's no fraction to it, you just stick a 1 under the 1. It's a numerator. Okay? Start factoring. Well, that one's already done. How does that one factor?
You have
X plus 3x minus 3.
No, it should be
No,
x
X
plus 3.
plus-
Was this really a 3x?
Yeah.
What factors of 9 add up to 3?
Oh no.
3 and 3 add up to 6.
Yeah.
9 and 1 add up to 10. Ooh, that one doesn't factor. What do we do with it? We leave it. We leave it like this. How does that factor? And it does. You've forgotten because we don't see it very often.
X
Oh, you
minus
wanted to
three,
do
X
the
minus
A,
three, X minus
like the
three.
square thing.
X minus 3 is the first one. You remember that?
And then
And the one that follows it is a trinomial built on this one. You remember?
Yes.
What goes here?
X squared
Good.
minus,
Plus.
wait, no,
Plus.
Plus
3x.
3x. Very good. You guys are remembering really well. That's great.
Plus 9.
Plus, always plus 9 on the back.
Oh wait, so that cancels out.
Yeah, that didn't factor, but when we factored this, it showed up again. So that does the whole thing will cancel. It's a big factor that didn't factor, but do you understand what's going on? Cancel that, and we end up with x plus 2 over x minus 3. What are the restrictions?
So X
Zero.
can't be.
Are there,
X can't be 9. X can't be 9.
are there no restrictions?
There are no restrictions, and here's why. Because the x values that make this thing 0 are imaginary. I told you that. When we learned to factor differences and sums of cubes, I said this trinomial, first of all, it will never factor. And its roots are imaginary every time. So there are no restrictions, no real restrictions on x. I don't expect you to find the imaginary ones. We'd be all day doing that. Okay. So in this particular case, when we factored cubes, this trinomial will never give you real x's. So if it cancels, there are no real x restrictions caused by this. And so this is it. There are no restrictions on x. Well, except for 3, but that's the obvious one. And so we don't write it. So that was an interesting one. You may run into cubes you have to deal with. Okay, take a look at example 5. I want you to look at it before I write it down because when Christian reads it to me, he's going to do it the right way. Example 5 is different from everything we've done so far because now we got a divide sign. So when you see a divide in your exercises, write the first one down just like it is and tip the second one over when you write it down. I think you got another multiplication problem. That's the only difference. So read it correctly. Okay, 7x over
2x minus 10.
2x minus 10?
Yep.
Okay,
And then it'll be multiplied.
it'll be times, right?
Yep. And then it'll
Okay.
be x squared. So then if we're flipping it, wouldn't the signs change too? Or no?
Nope.
So then it'd be
You're just going to
minus-
tip it over. You're just going to take that second one and tip it over.
and minus 11x.
Okay.
Plus 30.
Okay.
Or x squared minus 6x. That's it.
That's it. Okay, do you agree that he read it correctly and made it a multiplication problem?
Yes.
That's what you need to do. Turn that second one over. And then you're right back where we were and we start factoring. So it's no big deal. 7x, and then that's already factored, times. Is that one factor?
No, I don't think so.
No,
I do.
Okay, nice.
0 and 6.
What factors of 30 add up to 11?
Negative 5 and negative 6.
Well, 6 and 5. That goes here. And then you're right. They're both negative to get a negative 11 out of that. We're good, right?
Yeah.
Okay, so that's the numerator. On the denominator, we have, does this thing factor? Doesn't have a square on it, but
Yeah, in fact,
it factors. 2n.
X minus 5.
Don't forget to pull out what's common. Does this thing factor?
yeah.
What do we,
No.
yeah?
Like that.
Why?
X and
0. No, it'd be
X
minus
minus 6. So make sure you pull out what's common or divide out what every term has in common. That happened twice here, once here and once here. So now that everything's completely factored, we start canceling. There are no 7s. We'll not cancel with the 2, so I'm stuck with the 7 and the 2. Next thing I run into is an X. Oh, yep, there's an X. X minus 6 cancels. Oh, good. X minus 5 cancels. Holy cow, we've got 7 halves. And you still have to write the restrictions, even though there are no X's in the result. That seems really weird. But there were X's in the process. And so 7 halves is the answer, but you write X cannot be
5 or 6.
0, 5, or 6. I just wanted to list them in order. Here's your 0. See it? Yeah.
Why wouldn't you put -5 for 6?
Because it's the x value that makes it 0 that would make the denominator 0. 5 minus 5 is 0.
Okay.
And 6 minus 6 is 0, so they're positives. It's the things that would make the factor 0.
Oh.
0 makes that factor 0, so don't forget him. So even though we got a number with no x's in it, we still have to say x cannot be, which is weird, but that's what you gotta do.
So then it's just be the same thing for 6.
Same thing for 6, but what are you gonna do? How are you gonna turn that second one over? When it doesn't, when it's not a fraction.
With a 1.
Yeah, it's over 1 right now, so just put 1 over it. Write it. Go ahead, read it to me. What would you write?
6x squared plus x minus 15 over 4x squared times, oh no, that's done, sorry.
That's done?
Yeah.
Okay, all right.
Times 1 over 3x squared plus 5x.
Okay, this one's gonna be a little tougher, folks, because everything we factored so far, and most of what you're gonna factor has a 1 on the front of x squared. This one doesn't. So now we gotta think a little harder about whether this thing will factor, and if it does, how it factors. So you gotta consider factoring the front end and the back end, and these are our possibilities. Either 2 times 3 or 6 times 1 over here, and 3 times 5 or 1 times 15 over here. Which ones do you think are more likely?
3 and 5.
I think the 2 and the 3 and the 3 and the 5 are probably more likely. It doesn't mean it's guaranteed, but those are the ones I'm gonna try first so I have a better chance at hitting it. Because I think those are probably it. So I'm going to put 3x here and 2x here. It doesn't matter which order that goes in. And I'm going to put a 3 and a 5 here. I'm just slapping it down and I'm checking it. We got to subtract and we got to get a 1 out of the product, out of these products. So I got 15 minus 6. That's not 1. So I'm going to switch gears with these and see what happens. I got 5 here and a 1 or 2 here, 3 here. That gives me 9 minus 10. That's it. But I want the 10 to be positive, so I have to make the 5 positive, and I need the 9 to be negative so that I get a positive 1 out of their combination. You see what's going on? Okay, so I got that one factored. Hallelujah. I don't need to put a times 1 there. So I'm going to put a big line down here, and I've got a 4x squared. That's not going to factor.
Wait,
And-
can the square factor out of 4x?
There's nothing back here that needs to factor out of it. This is just 4 times x. Done. There's no factoring out because when we factor something out, there has to be at least 2 terms to factor it out of. Otherwise, it just hangs there. I mean, it's just 1 term. Nothing to factor out because there's no plus or minus signs. Does that make any sense? So this just hangs there like this. And this factors how? I'm putting a times here so I don't mix up my numbers and terms here.
It'd be
X, good. And
X.
3x.
3x,
Plus 5.
that's 5.
Oh.
That's one of those ones that's got something common in it because there was 2 terms and they've each got an X, so I pulled it out. You see? Everybody following? Okay, so now we start canceling, and that's the only thing I lose is that right there. So now what I have is 2x, oh no, just 2x minus 3 over 4x cubed.
And then the restriction would be x can't be -5. Can't be
No.
-5.
X cannot be -5/3.
Oh.
Remember, factors that have numbers on the front, they're zeros. The things that cause them to be 0 is back over front opposite sign. Remember? Do you remember that? So that had a 3 in front of it. We haven't seen that yet today, so we weren't thinking about it. But don't just put -5 because 3 times -5 plus 0. 3 times -5/3 is -5 plus 5 is 0. So it's back over front opposite sign is the whole answer for that. We good? One more example, and it's, of course, got a picture with it, which means there's context anyway. It says, the total annual amount I in millions, so keep that in mind, we're gonna call it I, and it's in millions of personal income earned in Alabama, and its annual population P in millions of people can be modeled by, now, you understand what we've got here? We've got a way of figuring the entire amount of money made by everyone who lives in Alabama. The entire amount of money made in paychecks in Alabama. And it says annual, so this is per year. That's why it's in millions. Probably should be in billions.
I was gonna say, that's not very much.
Well, if we end up with thousands of millions, that will be billions.
Well, that's true.
But we're going to stick with the millions. So that I right there is the entire pile of cash earned by employees that work in Alabama in 1 year. Okay? And P, which is the next equation they give us, is the total population of Alabama.
Okay, so I'll go with we do.
So what we want to find out is, if you read through it a little bit more, it says find a model M for the annual per capita income. What the heck does that mean, per capita income?
Like, for the amount of people that live in that area, how much they, right?
Don't they do the money that they all make and they divide by?
Per capita means per person. It's a really strange word, per person. And I think that includes all people who don't work as well, like kids and infants and work people and homeless people, stuff like that. I think that includes all that population. So it's an average per person income, even though some of those people don't work. Okay, you with me there? The population is given by that polynomial there. It's actually just linear. It's just a line. It says, estimate the per capita income in 2010. I guess this is all information about 2010. So what we need to do is take the total pile of cash and divide it by the number of people, don't we?
Yeah.
Total pile of cash, which is income, divided by the population in Alabama. So my job is to take that rational expression. You read it to me for the income?
Yeah. It says 6922 T plus 106,947 over
Jeez.
0.0063 T plus 1. And then
Population is?
0.0343 T plus 4.432.
And that's over 1.
Yeah.
So this is presented a slightly different way. This one over here, if you'll remember, was a division one, and then when Christian read it, he just turned it over and made a multiplication.
Could we do that with that one too?
Well, absolutely. It's just that the division sign is right there.
Yeah.
So what it really is this times that.
Yeah.
So what it really is this. I realize it's a whole bunch. That's the real problem.
Yep.
Okay. I hope that it's obvious to you that we cannot apply those strategies to this crap. Too many decimals, too many large numbers, too many very small numbers. Besides that, you can't factor with decimals. We've never taught you how to do that. And so you're going, well then, why do we even learn all this stuff if this is a practical application? The answer is, I don't know. It's good skills for you. I know you're going to need this kind of skill in trigonometry when we do things with sine and cosine, stuff like that. But this really doesn't tie to this. What they're trying to demonstrate for you with this problem is that quite often we have fractions divided by fractions. We have to deal with it. We have rational expressions that we have to mess with. The way we mess with it, though, is...
Yeah, I can understand.
And I don't understand the 2010. I didn't read the whole thing. It says where t equals 1 corresponds, if t equals 1, it corresponds to 2001. So when did we start?
So we started in 2001.
No, we started in 2000. That's a stupid way to express that. T equals 0 corresponds to 2000. If t equals 1, it corresponds to 2001.
Okay.
So our beginning time is really 2000. So if we want to find out the per capita income in 2010,
So we have to put the 10 right by the 692 and by the.
yeah, we got to replace this with 10, and this with 10, and this with 10. You all understand why we chose 10?
Yeah.
Even though they said 2001. Don't choose 9. That's t equals 0 is 2000. So we have to plunk this in our calculator, use lots of parentheses. So I'm going to start with parentheses. 22 times 10 plus 7 close it. Divided by parentheses. Here's how I'm going to do this so that you know. I'm going to put this in parentheses, and then I'm going to put a parenthesis, and I'm going to put this in one of them, times I'll put this in the other one, the whole
You said
denominator.
after
That's
the,
what I'm gonna do.
after the top one, you did parentheses.
On the top one, this is the syntax I'm gonna use without having to rewrite this thing, because it's a times problem now. I'm gonna put this in parentheses, and then I'm gonna hit a big fat divide sign. So my divide sign comes right after that parenthesis.
Yep.
And then I'm gonna put a parenthesis. The reason why is because I want the whole denominator wrapped in parentheses, but I want these individuals also wrapped in parentheses.
Oh, okay, I know.
See what I'm saying?
Yeah.
Okay, that's the syntax I would use. So that I can get it all done at once. When you hit enter, did you get anything reasonable? Does it seem reasonable to you? Go ahead and discuss with each other. And then check with what the book says the answer is and see if you got what they got. And if you didn't, let me come and look at your calculator so I can fix your thinking. No, you don't need any, well, you could use parentheses, but it's good times. Times is fine. Okay, keep going. You can hit enter there, but if you didn't put parentheses around it, putting divide right now is gonna be wrong.
So
You get parentheses, yeah.
Yeah, and
Now
then
go
use
divide
that.
by, and put a parentheses. There you go. Plus one, close it, open another. 1, 2, 3, 4, 3 times 10. Plus 4.432. Close it, close it.
I got the same, right exactly how I typed it, but exactly.
Anybody having trouble getting 34,707? Now, I don't suppose you guys at your age are aware, that is a really, really low income.
That's actually.
What in millions? So that's,
No.
Oh,
That was another thing I was gonna discuss with you. This income is in millions of dollars. This income is in millions of people. So millions cancel each other out
This is per
because
person.
you're dividing. The millions are out.
that's
That's per person. And remember, a lot of those people aren't working because they're too young. 34,000 is not a great income. But those that are making a pretty great income are spreading their wealth over those that don't in this calculation. You know what I'm saying? So it isn't that bad. Alabama, historically, has been a rather poor state. But they're not that. Okay. Okay, turn the page and voila, ready to go. Those of you doing this on paper, here's the assignments. Ready? 5 through 21 odd, 27, 31, 33, 35, and 43. And that's not much, that's 14 problems. If you are a good factorer, you can begin, as you see things in the book, you can begin by factoring them as you write them down. And then start canceling. But don't forget your restrictions, folks. See ya.